These are the solutions for the Chapter 9 test review sheet. So let's get started with problem number 1. These are involving this triangle called ABC, and we're going to be given certain parts of the triangle, and it's going to be our job to find the missing parts. So let's get started with this problem. We're told that the hypotenuse is 12. And this leg labeled as B is 5, and now we'll work on solving for side A and angles B and A. So since I'm dealing with numbers that are not rounded, these are given as whole numbers, I'm just going to use the Pythagorean theorem to find this missing side. I try to stay away from the Pythagorean theorem if these are decimal approximations, but in this case, it's going to work out fine. So remember, Pythagorean theorem is c squared is a squared plus b squared, and c squared is always the hypotenuse. Okay, so it's going to be 12 squared equals a squared, which is what I'm trying to find, plus b squared, which is here. 144 is equal to a squared plus 25. You grab your calculator and you get 119 is equal to a squared. And when you do the square root of both sides, according to the directions, we can round sides to the nearest tenth. So that means a is going to be 10.9. Alright, so we found the missing side, and now let's work on one of these missing angles. Once again, I'm going to use a trig function, but I'm going to stay away from the rounded side. I'm going to stick with these two whole number sides because I want to get as precise an answer as I possibly can. So I'm going to go for angle A. Okay, so looking out from angle A, I know what the adjacent side for A is. I also know what the hypotenuse of the triangle is. So the ratio of adjacent over hypotenuse is cosine. So I'm going to do cosine angle A is equal to 5, the adjacent side, divided by 12, the hypotenuse. To solve for A, I'm going to have to do the arc cosine, or that's just another word for inverse cosine, on both sides of this equation. Anytime you're looking for an angle measurement, you're going to be doing the inverse sine, cosine, or tangent. In this case, cosine, of course. So here's how it's going to look in your calculator. Okay, so you're going to do second cosine and then put 5/12 in, and let's see what you get. Okay, so in our calculator, we got the decimal 65.3756, but we're supposed to round measures of angles to the nearest degree, so angle A to the nearest degree will be 65 degrees. Okay, and now all that's left is to figure out angle B, and that's easy since we remember that the sum of these angles equal 180 degrees. So we just back off the 90-degree angle, we back off A that we just found as 65 degrees, and that gives us the measurement of our final angle, which is 25 degrees, and that is the measurement for angle B. Alright, so we found all of the parts that we were looking for, and that's your answer for number 1. Alright, so for number 2, this time we know what this side called B is. It measures as 15. Angle B measures at 75 degrees, and now we're supposed to find everything else. Okay, so let's just take a look from angle B's point of view, looking out from angle B. I know what the opposite side of angle B is, and let's say that I wanted to solve for the adjacent side. Alright, so let's think. The opposite side and the adjacent side, that is the ratio for tangent. Okay, tangent is opposite over adjacent. So I'm going to write the tangent ratio, tangent for the angle measured at 75 degrees, is the opposite side divided by the adjacent side. And now I solve for a, first by multiplying by a on both sides. And then I'm going to divide by tan 75 on both sides. And so a is going to be 15 divided by tan 75 in our calculator. Let's see what we get. Looks like 4.019, so we're supposed to round to the nearest tenth. So we'll just write that as 4.0. Alright, so we know what side A is. We also know what angle A is, right? Because that's just going to be, once again, 180 minus 90 minus 75. And so angle A is 15 degrees. Okay, so all that's left is to find this side C. And once again, I'm going to stay away from the Pythagorean theorem. I like to get as precise a measurement as I possibly can, and we rounded this decimal, so I don't like to rely on those. So I'm going to do another trig ratio. Alright, so let's think this time looking out from angle A. We can use this side, the adjacent side for A, since it's a whole number, and build the ratio of adjacent over hypotenuse, and of course that's cosine. So we can do cosine for that 15-degree angle equals the adjacent side divided by the hypotenuse, and I'm going to multiply by C on both sides. Then I'm going to divide by cosine 15 on both sides. And this is what I'm going to put into my calculator. So 15 divided by cosine 15. And that's 15.52. And to the nearest tenth, we'll say 15.5. And that is side C. Okay, and those are our answers for number 2. Alright, so for number 3, it's a little different because they tell us what side A is measured at. It's measured at 6. And then they give us this ratio for angle A, the sine ratio, which is 2/3. Well, that's kind of interesting because sine is opposite over hypotenuse. And didn't they just tell us that the opposite side was actually 6? So apparently 2/3 it represents the reduced fraction of what? Well, let's see. Again, opposite over hypotenuse. So let's think of an equivalent fraction. How did we go from 2? What do we have to multiply by to get from 2 to 6? That's multiplying by 3. So we'll have to do the same thing to the bottom. 3 times 3 is 9. So apparently 2/3 represents the reduced version of 6 over 9. Alright, so now I know what side C is. Side C is measured at 9. Remember, opposite over hypotenuse. 6 is the opposite for A. Hypotenuse then must be 9. Alright, so now it's just a matter of finding side B. These are nice whole numbers, so we can use the Pythagorean theorem. C squared, hypotenuse squared, is equal to A squared plus B squared. So 81 equals 36 plus B squared. 45 is equal to B squared. And now we do the square root of both sides. And we get 6.7 for B, rounded. Okay, so we got side B, we got side C, and now let's work on angle, either one. We can do angle A or B. Well, actually, we could do either angle, but let's just go with B. And again, we're going to stick with the whole numbers. So looking out from angle B, I'm going to use the adjacent side for B, and the hypotenuse of the triangle adjacent over hypotenuse is cosine. So cosine for angle B will be 6 over 9. Inverse cosine on both sides. Remember, anytime you're trying to find an angle, you're going to use what we call inverse or arc cosine. So let's do that in our calculator. So to the nearest angle, that turns out to be 48 degrees. All right, and now we can use our 180 minus 90 minus 48 to get angle A. So it looks like angle A is 42 degrees. Okay, so it looks like we got all the pieces. And we're ready to move on to number 4. Okay, number 4, I think it's always good in these word problems that you sketch a right triangle. So let's see, the recommended angle of elevation for a ladder used in firefighting is 75 degrees. So let's just draw a little picture here. I've got my building and the ladder is leaned against the building. Here's the ground. This is my angle of elevation, so it's like going upward from the ground is forming an angle of 75 degrees. The building, of course, forms a right angle with the ground. And the ladder is 21 feet. We want to know what this height is. At what height on the building does this ladder need to reach? All right, so we're looking for basically this height that I've labeled as X. Okay, so we're always looking from the angle that we're given, looking out from, in this case, the 75-degree angle. We're trying to find the opposite side for that angle. We know the hypotenuse of the right triangle. All right, so remember, the ratio of opposite over hypotenuse is sine. So sine 75 is equal to the opposite side divided by the hypotenuse. So to solve for x, I'm going to multiply by 21 on both sides. And grab our calculator, and we'll just type in 21 sine 75. And we get 20.28, and we're supposed to round to the nearest tenth. So we'll say that that height is approximately 20.3 feet. And that is your answer for number 4. All right, number 5, a little exercise in changing from degrees to radians, radians to degrees. So here's my conversion factor. If I want to go from degrees to radians, I multiply by pi radians over 180 degrees. And this needs to be in terms of some multiple of pi. So we're going to reduce. We're going to try to find a number that will hopefully divide into 180 and 315. And 45 divides into, that's always a good place to start if you're trying to reduce. Always go with the 30, 45, or 60, something like that as a starting point, because usually those will work. Those will divide in and reduce these pretty easily for you. But 315 divided by 45 is 7, and 180 divided by 45 is 4. The degrees basically cancel, and in radians this would be 7 pi over 4. That's my answer for number 5. For number 6, the conversion factor to go from radians to degrees, remember we always put pi, in this case, all across from each other diagonally, just like we put degrees diagonally across from themselves. So this is going to be 180 degrees over pi, just the flip of that previous conversion factor. So the pi's will cancel, and we can do some more canceling here. 4 goes into itself. 4 goes into 180, 45. And now we just need to multiply 9 times 45, and we get 405 degrees. And so that's my answer for number 6. So just be ready to use the appropriate conversion factor. All right, for number 7, we want to know the length of this arc. And if you forgot the formula, this is in our formula that's known as S. We find the length of the arc on a circle by taking the radius of the circle and multiplying by theta in radians. Okay, I want to stress that because that's really going to be helpful with number 8. But here we see that the angle is already in radians, so it's pretty simple. We just take the radius and we multiply by the angle, and we grab our calculator. And it's 53.8558, but we're supposed to go to the nearest tenth, so 53.9. And let's see, we're in centimeters. So that is my answer for number 7. Number 8, a similar problem. We have a radius of 12 inches. What is the arc length if the tire rotates 270 degrees? So that's our angle measurement, but again we have to put theta, or whatever the angle is, in terms of radians. So we're going to have to do a little conversion here. So 270 degrees times pi over 180 degrees. We can divide 90 into both of these. 90 into 270 goes 3. 90 into 180 goes 2. So in radians, this is 3 pi over 2. Now we can multiply by the radius times 12, and you can grab your calculator at this point. And this one is 56.548, and we're supposed to go to the nearest hundredth here, so 56.55, and this would be inches. All right, that's our answer for number 8. Moving right along. The terminal side of an angle theta is in standard position. It contains the following point. So this would be on our coordinate plane. We'll just put 16, negative 12. That goes down here in quadrant 4. Right, so the terminal side of this angle goes through that point. We're just going to drop a vertical down so that we can make a right triangle. Here's theta. Theta is always near the origin. So the distance this way along the triangle, x, is 16, and the distance this way, the y, is 12. And what we don't know is the hypotenuse. So let's do the Pythagorean theorem. C squared is equal to 16 squared plus 12 squared. And let's turn it over to our calculator. C squared is 400. So C is 20. All right, and so now we can make all of our trig ratios. We just have to remember that in quadrant 4, sine is negative in quadrant 4, tangent is also negative, and the reciprocals of those will be negative. All right, so let's just get right to it. Let's start with sine theta. So for theta, that's the opposite side over the hypotenuse. But again, sine is negative in quadrant 4. The y coordinate is negative, so sine is negative. And you never want to leave these unreduced if we can reduce. So we can make this become negative 3/5 dividing by 4. All right, cosine theta. All right, so looking out from theta, that's adjacent over hypotenuse. Cosine is positive in quadrant 4. So it starts off as 16 over 20, but when we reduce or simplify, we get 4/5. And tangent is y over x, or you can think in this case, you can do opposite over adjacent, 12 over 16. And since cosine is negative, one of these is negative, the other positive. That means tangent has to be negative. So we start off with negative 12/16, but when we reduce, we get negative 3/4. And now we work on the reciprocals of those. So for sine, that is cosecant. And so we just take negative 3/5 and flip it over. For cosine, that's secant. So that's going to be 5/4. And for tangent, of course, that's cotangent. And that's negative 4/3. And there you have all of your answers for number 9. Okay, here, this next block of problems, we're finding the exact value. No calculators here. So the unit circle would probably come in handy. Hopefully you've seen the unit circle, and hopefully you're getting good at it. Let's just say, for example, we can just do the 30, the 45, and the 60. Remember, there's a quick little trick you can utilize, which will help. All right, so all of our denominators are 2. Set up these ordered pairs. All denominators are 2. All the numerators have radicals. And so you just start at the top. 1, 2, 3, 1, 2, 3. And those are the ordered pairs. This is the 30 degree, this is the 45, and this is the 60. And all we have to do now is make sure we know where we are, what quadrant we're in, so we can make sure we change the signs accordingly. Okay, so cosine 135, well, 135 is 90 plus 45. So it's like this angle. If you're looking at the unit circle, it's the 100, of course, the 135 degree. But if you're doing reference angles, it's the 45 degree in quadrant 2. So just look at our 45 degree angle. Take the x coordinate, but in quadrant 2, cosine is negative. So I'm going to look at this ordered pair, but I'm going to remember, since this angle technically falls in quadrant 2, that's going to make cosine negative. It's negative √2/2. Okay, so sine 585 degrees. Well, that's all the way around 360. And then let's see how much more if you subtract. So that's 225. Okay, so all the way around we're back to what you would call square one. And now we'll go to the 225 degree angle. Okay, so that's 180 plus another 45. So we're right here. All right, once again, it's that same 45 degree angle ordered pair, but this time it's in quadrant 3. Okay, sine is the y coordinate, but in quadrant 3, sine is negative. So I'm going to take this from what we would call the reference angle, but I'm going to make it negative because sine is negative in quadrant 3. Okay, very good. I'll just draw that little picture again. The more you do this, the easier it gets. I think this will really come in handy. So again, this is 1/2 square root of 3/2 for the 60. For the 45, it's √2/2. And here it's √3/2 1/2. All right, so that comes in handy. Cotangent. So 4 pi over 3. Maybe you want to think of that as 1 1/3 pi. Okay, so here's pi, and then we're going to go another third of pi. Okay, and what is pi over 3 in degrees? Since it might be easier to track these angles, look at the unit circle in degrees. Pi over 3 in degrees is 60 degrees. Okay, so remember, this is the 60 degree angle. So we're basically looking at the other end of that angle. Okay, pi plus another third of pi. Well, in quadrant 3, both of these coordinates from this ordered pair are negative. All right, and when we do tangent, we do y over x. And since both of these are negative, tangent becomes positive. All right, so I'm going to start with tangent, and then we'll look at cotangent. All right, so the 2's would cancel. Tangent is the square root of 3. Well, cotangent is the reciprocal of that. So it's 1 over the square root of 3, and then we just rationalize the denominator, and we get the square root of 3 over 3. And tangent is positive in quadrant 3. Okay, secant, negative 9 pi over 4, so that's another way of saying negative 2 1/4 pi. All right, so we start off going in a negative direction. Negative 2 pi, remember this is 1 pi, this would be negative 2 pi, and then a fourth. So here we are, that same angle again. We're wearing this one out. It's that same 45-degree angle, but this time it's in quadrant 4. All right, so it's square root of 2 over 2, negative square root of 2 over 2, down here in quadrant 4. And secant is the reciprocal of cosine. All right, so cosine for this angle, negative 9 pi over 4, is root 2 over 2. Well, if we want secant, we're going to have to take that and flip it over and rationalize. And so we end up with 2 times root 2 over 2, and the 2's cancel. So my answer for number 13 is just root 2. Okay, very good. I've got a couple more of these, so let's see if we can figure this out pretty quickly. Cosine negative 120, so this is negative 90, and then another 30. Okay, so here is that angle, and let's compare it to the angle up here that we already defined several times. 1/2 square root of 3 over 2 would be this ordered pair on that end of that terminal side. So in quadrant 3, this would be negative 1/2 negative square root of 3 over 2. Okay, see how that works? All right, so cosine is the x-coordinate, and so that's pretty simple. It's negative 1/2. All right, let's do this one. This is negative 7 pi over 4. That's another way of saying negative 1 3/4 pi. So once again, just get a little unit circle picture here. Negative 1 pi and then another 3/4 pi. It's been a popular angle today. We're back to that 45-degree angle, and it's the square root of 2 over 2, square root of 2 over 2. Sine is positive, of course, in quadrant 1. Sine is the y-coordinate, and so my answer here is just the square root of 2 over 2. Okay, I hope those are getting easier for you. So let's take a look now at period. How do we know what the period of a function is? Well, the period is the horizontal length of a cycle. Well, what's a cycle? Well, let's start here at the origin, and let's trace this graph until it gets to a point where it just starts to repeat itself. Okay, now I'm back to where I started. Okay, I'm back to the x-axis, and from there it's just repetition. Okay, so a period is this horizontal length, and you can get that pretty easily from the x-axis. The answer here would be 6. Okay, the graph below represents the translation of a parent function, and we want to know what the function is represented. Well, first of all, you have to identify which parent is being involved, and this is the parent y equals x squared. Every time you see a parabola, it's a translation, or it is the parent function y equals x squared. Well, the parent always has its vertex at the origin. Well, this graph has been shifted from there 2 to the right and 4 down. And so the way we handle this translation inside the parentheses, we take care of the horizontal shift, and it went 2 to the right, so we do that with x minus 2. The vertical shift is handled outside of the parentheses, and 4 down means minus 4. So that's my answer for number 19. I'm going to take just a minute and identify these other parent functions, just so I'll just do rough sketches, just so you can have a basic idea of what they look like. Okay, so up here I'll just start with the absolute value function, y equals absolute value of x. That has vertex at the origin, and it's the V shape. So it looks like this. Okay, and then we've got other parents like y equals the square root of x, and we've dealt with that one a few times. It does something like this. We've also done the cube root of x, and it looks like this. It goes in both directions. Let's give you a little rough sketch here. All right, let's see, what have y equals x cubed. I haven't looked at that one a lot, but it's pretty easy. It goes through the origin. Just think of 2 cubed is 8, negative 2 cubed is negative 8. So it's going to do something like this. All right, we've done growth and decay, so let me do b as growth. Okay, so if b is growth, it's going to go through 0, 1. It's going to approach the x-axis forever, going to negative infinity, and then it's going to shoot up to positive infinity, going along the positive y-axis. Here is decay. Okay, so it's really the same function, but if b is a number between 0 and 1, then you've got decay. And it looks like this. Still going through 0, 1, but it'll approach from the other side. All right, and then the only one I haven't done is I did not do this one. And I'll tell you what, for watching this, I won't have you worry about that one for your tests. So if you'll just focus on these, and we'll catch this one on a later test. Okay, I want you to know how to handle rational exponents. We need to turn these first into radical form. Okay, so this fraction works like this. We know 16 is going to go into the radical, but the bottom part of the fraction will always be the root. Now I'm going to write 2 in here, even though we technically don't write 2 for square roots, but I just want you to see where these two parts of the fraction are going to go. The denominator will be the root. The top number will be the exponent for the number under the radical. And so to simplify these without a calculator, just think, first of all, square root of 16, which is 4, and then you can raise that result 4 to the third power, and you'll get your answer 64. Okay, negative exponents force us first to write the reciprocal of the base. The base in this case is 8. The reciprocal of 8 is 1 over 8. And then I can change the exponent to positive. So now I'm going to do this same thing. I'm going to make this rational exponent become radical. All right, so again, the bottom number of the fraction is the root or the index. The top number becomes the exponent. And just break it up into two parts. The cube root of 8 is 2. 2 to the second power is 4. My answer here is 1/4. Okay, same thing here, negative exponents. So I'm going to change this to 1 over 27 to the positive 4/3. In radical form, this is going to be the cube root of 27 to the 4th power. Taking the cube root of 27, I get 3 to the 4th power, and that's 1 over 81. All right, so those are quick and easy. I just wanted to make sure you understand how to deal with rational, that just means fraction, exponents, how they become radicals. Okay, so this is the exercise on imaginary numbers. I'm going to simplify this by using the square root of -1 times the square root of 16 times the square root of 3. I just factored it out. Two of these radicals can be fully simplified without radicals. The square root of 16 is 4, square root of -1 is I, and then the square root of 3 stays radical. It cannot be simplified. 24, before multiplying I do powers. So I'm going to change -6i raised to the second into 36i squared. Just remember that I squared is equal to -1. So anytime you see I squared, you need to think of it as -1. So this is really 36 times -1, which is -36. Now I can multiply these together, and it becomes -144i. Okay, before you can multiply radicals together, they have to be real numbers, and neither one of these are real numbers, so I need to simplify them first. I times the square root of 10, and simplifying this one, I'm going to get 2i times the square root of 6. I multiply the non-radical parts together, I get 2i squared. I multiply the radicals together, I get root 60. Remember, I squared is -1, so that's -2. And I'm going to simplify the square root of 60 using the square root of 4 times the square root of 15. The square root of 4 is 2. 2 times -2 is -4 times the square root of 15. This is my final answer. Okay, 26. I want you to be able to simplify I to any power. So once again, I know I've said this before, but if you remember the first 4 powers, then you can basically get any of the others, because after this they just start repeating. Notice that I to the 1st is the same thing as I to the 5th, which will be the same thing as I to the 9th, which is the same thing as I to the 13th. I just add 4. I squared is I to the 6th, is I to the 10th, is I to the... You get the picture. Well, I to the 4th is the same thing as I to the 40th. 4, 8, 12, 6. If we just keep on incrementing this exponent by 4, we're going to come back to 1. So if we think of this as I to the 40th times I to the 1st, and we know that I to the 4th is the same thing as I to the 40th, that's really like saying 1 times I. So my answer here is just I. Simplifying complex numbers involves using the conjugate, and the conjugate of 2 minus 3i is 2 plus 3i. So I'm going to use FOIL on the top. So 6 times 2 is 12, 6 times 3i is 18i, 2 times -i is -2i, and -i times 3i is -3i squared. But again, since I squared is -1, I'm going to make this become plus 3. -3 times -1. Alright, and then on the bottom, for conjugates, we just need to worry about multiplying the first 2 terms together and the last 2 terms together. But again, since I squared is -1, that's like -9 times -1. That's plus 9, and that makes this 13. 4 plus 9 is 13. And we'll simplify by combining like terms. Start with the real parts first. 12 plus 3 is 15. 18 minus 2 is 16i. And the complex numbers, remember, should always be written like this, and in cases of fractions like this, we're going to break them up into 2 parts. So just divide by 13 into both parts, and that's your answer for number 27. Okay, 28, we are multiplying two complex numbers together, and that involves FOIL basically. So we do negative 18, and then this is plus 18i, negative 6 times negative 3i. In the middle it would be negative 3i, and on the end, the last terms will be plus 3i squared, which makes negative 3. And we combine like terms, and we put the real number part first, always. So negative 18 minus 3 is negative 21. And when we combine the imaginary numbers, 18 minus 3 is plus 15i. And that's my answer for number 28. Okay, so let's talk about the discriminant. The discriminant is, when you think about the quadratic formula, just think about this part, the part underneath the radical. b squared minus 4ac. So if I'm labeling the quadratic equation in this problem, a is 6, b is negative 1, and c is negative 5. Alright, so let's find the value or the number representing the discriminant. So b squared, that's negative 1 squared, minus 4 times 6 times negative 5. And negative 1 squared is 1 minus, and this is 24 times negative 5, which is negative 120. And 1 plus negative 120 is 121. So that is the discriminant. The fact that the discriminant is positive means that there's going to be two real number roots. And as far as the graph is concerned, since there's two real roots, we're going to have two x-intercepts. Or it's going to cross the x-axis in two different places. Alright, so just be ready. If the discriminant should have been negative, a negative discriminant, you would have said there are two imaginary roots, no x-intercepts. The graph would not cross the x-axis. If the discriminant happened to be 0, we hit the x-axis one time, one x-intercept, and that happens to be the vertex. Okay, so don't just think it's got to be a positive and you just memorize the answer. Okay, so we've done letter A, that's 121. We've done letter B, and now let's find the solutions. I'm going to use factoring. So I'm going to factor this as two linear binomials using the factors of 6x squared as 6x times x, the factors of negative 5. We'll do negative 1 and positive 5, just a quick little FOIL check. This gives me negative 6x on the outside plus 5x on the inside makes negative 1. So that works. Setting both of my factors equal to 0 and solving, I get x is equal to negative 5/6, and over here I get x is equal to 1. So those are my two solutions. Okay, that takes care of number 29. Let's move on to number 30, finding the solution to a matrix equation using an inverse matrix. So first I'm going to subtract this matrix on the left from the matrix on the right. I'm essentially subtracting it from both sides. Alright, so let's see what that makes our equation look like. Okay, so subtracting, I'm going to do 3 minus 1, that's 2. 8 minus 9 is negative 1. 6 minus 3 is 3. Negative 6 minus negative 8 is 2. Alright, so to find the inverse, I need to find the determinant. And to find the determinant of a 2 by 2 matrix, you multiply this way first. We call this the A and the D elements. 12 times 3 is 36. Subtract, now multiply this way. 5 times 7 is 35. The determinant is 1. So here is the formula, if you will, for finding the inverse. It's 1 over the determinant multiplied by a rearranged, changed up original matrix, the matrix that we're trying to find the inverse of. We switch places with these elements called A and D. I'm actually going to call them like that. So notice how I switch those two, switch places, and now these, the B and the C elements, are going to change signs. So this is the formula for finding the inverse. So putting it into practice with this problem, it's 1 divided by the determinant multiplied by, I'm going to switch places with the 12 and the 3. I'm going to change the signs of the 7 and the 5. And when I multiply by 1, it doesn't change anything. This is my inverse. And now to get my answer, I'm going to multiply by this matrix on the right side of the equation. And so I just have to remember what matrix multiplication looks like. Okay, so let's run through it. Matrix multiplication is always row times column, row times column. So I'm going to set up 4 blanks. It's a 2 by 2 product. So 3 times 2 is 6, plus negative 7 times 3 is negative 21. And when I add those together, I get negative 15. To get row 1, column 2, I do 3 times negative 1, that's negative 3, plus negative 7 times 2, it's negative 14, so that makes negative 17. To get row 2, column 1, I'm going to use row 2 times column 1. Negative 5 times 2 is negative 10, plus 12 times 3 is 36, so this is going to be 26. And now I'm going to use row 2 times column 2. Negative 5 times negative 1 is 5, plus 12 times 2 is 24. That's 29. And this is my answer using an inverse matrix. Okay, let's solve this log equation. And we've got to take multiple logs and combine them into one. And in order to do that, I need to put my log expressions on the same side. So I'm going to subtract log base 10 of c plus 1 from both sides, and I'm going to add 2 to both sides. The purpose for that is I need these logs to be on the same side so I can put them together as a single log using the quotient property. Okay, this is the quotient property. 2 logs of the same base that are being subtracted can be put together as a single log using division. Now, log equations always have to be converted into exponential form. The base of 10 raised to the exponent 2 equals this fraction. Alright, so 100 equals c squared minus 1 over c plus 1 multiplied by c plus 1 on both sides. Okay, setting it equal to 0. I get c squared minus 100c minus 101. Factoring using the factors of negative 101, that would be negative 101 and plus 1. So I get 2 solutions, but there's a problem with negative 1. First of all, when I plug it back in, I get log base 10 of 0, and there's no way to raise 10 to a power to make it equal 0. So I can't use the negative answer, only the positive, and so my answer is 101. 32. This is an exponential equation, so here's the rule. Exponential, change to log. If you're given log, like the previous problem, change to exponential. Okay, so this is exponential. Here it is as a log equation. Log base 8 of 6.4 equals the exponent z minus 4. Now to get this, I'm going to use the change of base formula. Change of base. And it looks like this: log in your calculator of the top number divided by log of the base. So let's see what that looks like. Okay, so using the change of base formula, you should be looking at 0.892690063 in your calculator, and just leave it there. So to solve for z, we're just going to do plus 4. Add 4 to that number, and our answer is 4.8927 to the 10,000th place. Okay, so can't stress enough how to change exponential equations to log form so you can solve them, and then changing log equations to exponential form so you can solve them. All right, that takes us to number 33, and I want you to know about points of discontinuity. So let's start first of all with any x-intercepts. And if we have x-intercepts, they will result from letting our numerator be set to 0 and solve for any variable. If there is no variable in the numerator, then we have no x-intercepts. But in this case, we do. We're going to cross the x-axis at the origin. Okay, let's do vertical asymptotes. They represent numbers that make the denominator 0. And we have 2 of those. We have a vertical asymptote at x equals -2, and we have another one at x equals 5. Horizontal asymptotes, in this case we have one at y equals 0 because the denominator degree is larger than the numerator degree. There is no oblique asymptote because the numerator degree has to be higher by 1 degree, and obviously it's not. So there is no oblique asymptote. There are no holes because there isn't a number that makes both numerator and denominator 0. And so that is our answer to number 33. 34, we got to subtract these two fractions that do not have a common denominator. So we first need to factor so that we can come up with a common denominator. So first of all, I'm on this right side. On the left side, I factored out a GCF, and I'm doing the same thing on the right side. Now I'm going to keep factoring this right denominator using 2 linear binomials multiplied together. Okay, so the factoring helps me see the lowest common denominator. And it's going to be 6 times x minus 3 times 2x minus 1. Alright, so divide the original factored denominator into the common denominator, and whatever doesn't cancel multiplies. So 2x minus 1 is going to multiply by 5, and that's 10x minus 5. Over here, 2x minus 1 cancels, x minus 3 cancels, 2 goes into 6 3 times. So I'm going to multiply 3 times x minus 1, that's 3x minus 3. And now I put the numerators together, combine like terms. 10x minus 3x is 7x. Negative 5 minus negative 3 is -2 or minus 2 all over the common denominator. And since I can't factor the numerator anymore, this ends up being my answer. Okay, now this is an equation we're trying to solve, and we're going to do this by clearing these denominators. Alright, so we need to know what the lowest common denominator is. And when we find that, we're going to multiply by that on both sides. So the lowest common denominator is going to be x plus 3 times x minus 2. I'm multiplying by that on both sides. Okay, so when I divide, I'm going to divide to clear this out, make it cancel. Now it's gone. And then x minus 2 will multiply by 14. Okay, same thing here. This time the x minus 2 is going to go, leaving x plus 3 times 10. 10x plus 30. And then here, everything goes. It's like 1 times 122. Combine like terms. 14 plus 10 is 24x, plus 2 is 122. Subtract 2 from both sides. Divide by 24, and our answer is x equals 5. Okay, and then this problem, similar, we need to factor so that we can find the LCD. So let's get it all in factored form, and it looks like the lowest common denominator is going to be 12 times n plus 1 times n minus 1. Alright, so let's divide. If we take the factored, we really don't need to look at these now. I think it's easier to look at the factored form. You can see the n plus 1s will cancel. 12 divided by 3 is 4, so I'm going to be multiplying 7n times 4n minus 4. And that's 28n squared minus 28n. Okay, over here, 4 divided into 12 is 3. The n minus 1's cancel, so it's 3 times n plus 1. That's 3n plus 3. And I got to be careful here because this is subtraction. So this is 15n. Starts off as plus 15, but I'm going to be subtracting both of these. So got to be careful. All right, over here the n plus 1's cancel. 12 divided by 2 is 6. 6 times n minus 1. 6n minus 6. And multiply that by 3n. 18n squared minus 18n. All right, so let's simplify. Okay, and let's put our like terms together on the right side first. 28n squared minus 43n minus 15, 18n squared minus 18n. I'm going to subtract 18n squared from both sides. I'm going to add 18n to both sides. Okay, and I can factor out 5. And I can factor this as 2 linear binomials, 2n, n. This will be minus 3 and plus 1. And so I get my answers. My solutions will be negative 1/2 and positive 3. All right, looks like that's good. I think the problems I forgot, I think I need to go back and do the graph, so I will do that now. Okay, I jumped over numbers 17 and 18, so we'll wrap it up with these two graphs. First of all, we're supposed to find the amplitude and the period, so let's do that real fast. The amplitude in this case is 4, so we can go ahead and make a mark here. This will be positive 4, and this will be negative 4. The period is always found by taking 360 and dividing whatever's in front of theta. That 2 didn't turn out too good. So we'll do 360 degrees divided by 2, and that's 180 degrees. All right. In our graph interval, the marks that we make on our theta axis will be 180 divided by 4. And that's just, I think that's a good way to help organize the graph. Gives us some good inputs. So that's going to be 45. All right, so I'm going to make 45, 90, 135, 180, 225, 270, 315, 360. We made it all the way around. And so my graph, the sine graph, is going to look like this. If you start with 0, you input 0 for theta. Sine theta, sine 0 is 0. 2 times 0 is 0. And so we end up with a y-coordinate of 0. Okay? If we let theta be 45, then it's like saying sine 90. Okay? 2 times 45. Sine 90 is 1, and 1 times 4 is 4. And then you can kind of get the picture. If we do 90 for theta and multiply that by 2, we're doing sine 180. That's 0, and 4 times 0 is 0. Here we're going to get negative 4. It's sine 270, which is negative 1. Negative 1 times 4, negative 4. And then this is one cycle. We already determined that, or a period. The cycle is the actual movement of the graph. The period is the horizontal length of that cycle. So really we just need to repeat all of this one more time and then connect it, and we will be done with this graph. Alright, so we'll just use a curve to try to connect these dots. And that's good enough there. And so that will be your answer for 17. Number 18 is a cosine graph. And this time our amplitude is 1. The amplitude is the absolute value of what's in front of sine or cosine. Period, again, is 360, in this case divided by half. So it's going to be 720. And then if we do 720 divided by 4, we get our graph interval. So that's going to be 180 degrees, 360 degrees, 540 degrees, 720 degrees. And that's as far as we need to go. So let's do our amplitude of 1 and negative 1. And so cosine will start up here. If we do cosine 0, 1/2 times 0 is still 0, and cosine 0 is 1. Here we'll do theta is 180 degrees, 1/2 times 80 is 90, cosine 90 is 0. 1/2 times 360 is 180, that's cosine 180 is negative 1. Then we're back to 540, and then up to 720. Okay, and so that is one complete period. You notice how we've gone through, and now we're starting all over again. And I'll connect those dots, and we will be done. Okay, and that completes it. Don't know why I skipped those earlier, but I did. And I hope this helps you get ready for your test. If you have any questions, let me know.